Alright, number one, we're going to start factoring, so I can pull out a 3a squared, leaving me with a squared plus 4 over a minus 2 times a minus 2. Second fraction, I can pull out 4, which leaves me with a squared minus 4, and then a squared minus 4 is a difference of squares, which factors to a plus 2, a minus 2. So I need to factor that completely. Over, I can pull out 6a cubed, leaving me with a squared plus 4. Now I go to cancel common factors. I see an a squared plus 4 that can cancel. A minus 2 can cancel. The 3 can simplify with the 6, leaving the 6 a 2, but then 4 and 2 can simplify, turning the 4 into a 2. I have an a squared over an a cubed, so I can cancel out a squared, leaving me with an a. Looks like that's all that's going to cancel, so in my numerator I have 2 times a plus 2. My denominator is an a times a minus 2. Second fraction, x minus 5 times x plus 3 over x minus 2, x minus 3. Second fraction, x plus 6, x minus 2, and then in the denominator x plus 5, x minus 1. I don't have very much that cancels here. X minus 2's cancel. And it looks like that's all, because my 5's have different signs, my 3's have different signs, so I got a lot left in my answer. So I have x minus 5 times x plus 3 times x plus 6 for a denominator, x minus 3, x plus 5, and x minus 1. Number 3, 3 times z plus 2. For the denominator, I get 2z minus 3, 2z plus 1. Since it's division, I've got to flip it, so I can do a multiplication problem. So 2z squared plus 3z plus 1 goes to the top. It factors to 2z plus 1, z plus 1. And then the z squared plus 3z plus 2 goes to the bottom and factors to z plus 1, z plus 2. Now I'm looking for common factors. I can cancel out z plus 1's, z plus 2's, 2z plus 1's, leaving me with 3 over 2z minus 3. Number 4, that numerator, it's a complex fraction, so that numerator, I can factor out a 4a, which leaves me with a minus 3. Its denominator is going to become a minus 3 times a plus 2. And then its division, so I'm going to multiply by the reciprocal. So I look at the a squared plus 3, a plus 2 for the top, a plus 2, a plus 1. And then 6a cubed plus 6a squared is going to go to the bottom. I can pull out a 6a squared, leaving me with a plus 1. I cancel out a plus 1's, a plus 2's, a minus 3's. 4 and 6 will simplify to 2 and 3. I can cancel out an a, leaving me with an a in the bottom. So all I have left in the numerator is a 2. For the denominator, I just have 3a. Now number 5, need a common denominator, which is a plus 2 times a plus 4. So the first fraction needed an a plus 4, distribute the 2 to that, so it'll be 2a plus 8. Second fraction needed the a plus 2, distribute your 3, 3a plus 6. Combine those numerators, 5a plus 14 over the common denominator. Numerator doesn't factor, so there's nothing to cancel. Number 6, factor the denominators first before we determine the least common denominator. So a plus 3 and a minus 1. Second fraction will be in an a minus 1 and an a minus 2. So my LCD includes an a plus 3, an a minus 1, and an a minus 2. So first fraction, it didn't have the a minus 2, so multiply the 3 to the a minus 2, giving you 3a minus 6. Second fraction didn't have the a plus 3, so we bring that into the numerator, giving us 2a plus 6. Now combine the fractions together. Remember that it is subtraction. 3a minus 2a is a. Negative 6 minus 6 is negative 12. That's over the common denominator. There are no common factors here. That numerator doesn't factor, so what's left is our answer. 7. Least common denominator is going to include an x plus 7 and an x minus 8. First fraction, I've got to bring in the x minus 8, so we get 3x minus 24. Second fraction needed the x plus 7, so we distribute the 4x plus 28. Add the numerator, 7x plus 4 over the LCD. Numerator doesn't factor, no common factors, so I'm finished. Number 8, the denominators do factor. I can factor out a 2 from both of them. So the least common denominator will include a 2, an n plus 3, and an n plus 2. First fraction didn't have the n plus 2, so bring in the 5 to that, 5n plus 10. Second fraction didn't have the n plus 3, so distribute your 3n plus 9. Notice the subtraction problem, so 5n minus 3n is 2n. 10 minus 9 is 1, so 2n plus 1 over the common denominator. 2n plus 1 doesn't factor, there are no common factors, so what's left is the answer. Number 9, I've got to first add that numerator together. I need a common denominator of x plus 1 and x minus 2. First fraction needed the x minus 2, so we get 2x minus 4. Second fraction needed x plus 1, so we get 3x plus 3. Add those two together now, so in total I have 5x minus 1 over that common denominator. Okay, so now I can think about the fact that it's a complex fraction, so it's division, so I'm going to multiply by the reciprocal. So x plus 1 goes to the top, 5x minus 1 goes to the bottom, neither of those factor. 5x minus 1's cancel, x plus 1's cancel. All I'm left with in the bottom is an x minus 2, so the numerator is just a 1. So 1 over x minus 2. Sorry, go there. Number 2, multiplication, or it's an equation we're trying to solve, so the least common denominator here would be 3n. So I'm going to multiply 3n to everything. 3n times 2 gives us 6n. When I take 3n times 4 over n, the n's will cancel, leaving me with 3 times 4, which is 12, plus 3n times 1 over 3. The 3's will cancel, leaving me with just n. Subtract my n. 5n equals 12. I'm going to have a fraction here, 12 fifths. Number 11. The least common denominator here is just y. It's the only denominator, so I'm going to multiply everything by y. When you multiply it to that first fraction, the y's cancel, leaving you with negative 12 equals, now distribute the y on the right side, we get y squared minus 7y. This is probably going to be a factoring problem, so I'll add my 12 over. Y minus 3 and y minus 4. So my answers are positive 3, positive 4. Ensure that neither of them make the denominator equal 0. I didn't check that on number 10, I should have. But nope, the denominator doesn't become 0 on 10, nor does it on 11, so both of those answers will work. Number 12, I need to factor that first denominator, p plus 3, p plus 4. So it looks like p plus 3 times p plus 4 will be the least common denominator. It includes every factor that's in the denominator. So distribute it through. When you multiply it to the first fraction, it will cancel out, the LCD will cancel out with the denominator, so we'll just be left with the 12p plus 9, 19, I guess. Minus, actually what I might do, because I'm going to have to distribute, instead of thinking of minus 3, I might think of it as plus and negative 3. That might help out a little bit here. It already had the p plus 3, so that will cancel. So I'm bringing in p plus 4. So distribute negative 3 to p plus 4. So we get negative 3p minus 12. On the other side, when you distribute in, your p plus 4s will cancel. You'll have 5 times p plus 3. That's 5p plus 15. I can simplify the left side a little bit. 9p plus 7 equals the 5p plus 15. Subtract 5p, subtract 7. I get 4p equals 8, so p would have to be 2. Does not make a denominator equal 0, so I don't have to throw it out. So 2 should work. Number 13, this is like the 8-3 type of graphing. Both 13 and 14 are that way, where we have the h and the k. So we look at the denominator to determine our vertical asymptote. X equals, and we switch signs, so positive 3. And then in this section, 13, 14, your horizontal asymptote was 0 unless you had a k value, which I do. So negative 4. So vertical at 3, horizontal at negative 4. Table of values, get a couple points. Since we're not using a graphing calculator, I don't have an expectation for a ton of points. I'm really content with just 1 on each side of that vertical asymptote. So I might plug in 2, plug in 4. When I plug in 2, that denominator become negative 1. Negative 1 over negative 1 is positive 1, so I get 1 minus 4, that's negative 3. When I plug in 4, your denominator becomes 1. Negative 1 over 1 is negative 1. Minus 4 is negative 5. So 2, negative 3, 4, negative 5. So we know it's going to be branches of a hyperbola. We know what quadrants they're in because of the ordered pairs we just picked. Curve. Hit your points, stay in your quadrants. Okay, number 14, vertical asymptote is negative 1. Horizontal will be at negative 2. I will say, when I first did number 14, I did a different graphing problem. I changed it, but I did not change the graph. That's why you're going to see it's not actually going to fit on the graph. So you can go by 2s, you can extend the graph like I'm going to do here. When I surround negative 1, I'm going to pick negative 2 and 0. When I plug in negative 2, I get negative 4. When I plug in 0, I get 0. So I'm kind of giving my best guess on that negative 2, negative 4. Draw branches of a hyperbola that hit those points and don't cross or touch asymptotes. Number 15, now for 15, 16, we move into the next section, 8, 4. Still look at the denominator when you're finding your vertical asymptotes. That denominator on 15 needs to be factored. So x minus 4x plus 2. So I'm going to have zeros at 4 and at negative 2, so those are both going to be vertical asymptotes. Since the degree of the numerator is less than the degree of the denominator, your horizontal asymptote is 0. So now I'm going to pick points in all 3 parts to the left of negative 2, so I'm going to pick negative 3. In between them, I might pick 1 because that's about right in the middle, and then to the right of 4, I might pick 5. When you plug in negative 3, you get 3/7. When you plug in 1, you get negative 1/3. When you plug in 5, you get 3/7. So negative 3, 3/7. It's not quite a half. 1, negative 1/3, about there, and then 5 is 3/7 again. So the far left is going to look like a branch of a hyperbola. Hit your point. Don't cross your asymptotes. The far right is going to do the same thing. Look like a branch of a hyperbola. And between them, it's going to look more like a parabola. We know it's not a parabola because there's an asymptote on each side, so it can't go on forever to the right and the left. But we know it's going to be down because negative 1/3 was below the horizontal asymptote. So there's our graph. Number 16, vertical asymptote at negative 2. The degree of the top and the bottom are the same. That means for your vertical asymptote, you look at the leading coefficients. 1 over 1 is going to simplify to 1. Your table of values, pick something to the left of negative 2, maybe negative 3, pick something to the right, maybe negative 1. When I plug in negative 3, I get 3. When I plug in negative 1, I get negative 1. Oh, sorry. I went to positive 3, or negative 3 for some reason. Should have been negative 3, positive 3, like I wrote down. And negative 1, negative 1. So, stay within your quadrants, within your asymptotes. And there we go. Let's go to the back page. Got some word problems now. They give us an equation for part 17. We don't have to come up with the equation. They give it to us. We need to graph it. I do care about vertical and horizontal asymptotes when I graph. Vertical asymptote would be at 0. The degree is the same for both top and bottom, so think about leading coefficients. Leading coefficient in the numerator is actually the 1 because the x term would come first. In the bottom it's 6, so 1 over 6. So vertical at 0, and then 1/6 is about here. They do tell us just to stay in the upper quadrant, or the first quadrant, so let's pick a point or two. There, maybe I would plug in 1, so my numerator would be 7, my denominator is still 7/6, so it's 1 and 7/6. That's probably enough because I know it's going to be a branch of a hyperbola. I don't have to worry about the rest of the graph. They just told me to look at this quadrant. So there's a graph. Okay, if Tawa's father can complete the job in 4 hours alone, and they're giving him x. X is the number of hours it takes him. So if x is 4 is what they're saying, what portion of the job can they complete together in 1 hour? So really all I have to do is plug in 4. Take your equation, plug in 4. So 6 plus 4 is 10. 6 times 4 is 24, so it's 10/24, which simplifies to 5/12. They could get 5/12, not quite half of the job done in an hour. What domain and range values are meaningful in the context of the problem? I'm not going to get too specific here. I know there was an asymptote at 1/6, so it has to be greater than 1/6. We're obviously not going to paint the shed more than once, so there's kind of a top bound to it as well. But I'm really just going to say positive. Positive values. And the reason we want positive values is because he's not going to work a negative amount of time, and they're not going to paint a negative number of sheds, or a negative portion of sheds. So really, positive domain and range values are all we really care about because of that. Okay, batting average. Okay, so part A. So he had, prior to this season, he already had 2,067 hits. He adds another 183 hits on during that season. He had 67 for at-bats prior to that season, and it tells us X at-bats. We don't know the number of at-bats. So here's the equation. If you want to simplify that numerator, we can. That would be 2250. I can't do anything to that denominator. I could switch the order, I guess, so it's in descending order. But, that would be sufficient for an equation. Part B, then, determine the asymptotes. Vertical asymptote, what would make the denominator equal 0? Well, that would be negative 6767. Not going to have that many hits. Obviously, it's not going to have negative hits. That doesn't really make sense. Or at-bats, rather, negative at-bats. Horizontal asymptote, the degree of the top is less than the degree of the bottom. Therefore, it's going to be 0, y equals 0. Part C, what is the meaning of the horizontal asymptote? The horizontal asymptote was 0. Well, it means if I graph it, eventually, as the number of at-bats approaches infinity, I'll write this down, as the number of at-bats approaches infinity, his average will get closer to 0. His average will approach 0. And that's true because the number of at-bats are changing, not the number of hits. The number of hits are staying constant because the number of hits is constant. The only thing we're changing is his at-bats. Now, we know he's not going to really get an infinite number of at-bats in that season and have an average near 0, but that's what that means. Okay, now we get into variation. So this is section 8.5. Y varies inversely. So if I'm doing my proportions, I actually technically have a proportion here, just multiplied. Y sub 1 is equal to x sub 1, or sorry, y sub 1 x sub 1 is equal to y2 x sub 2. The first order pair, y is 5, x is 5, use that as y sub 1 x sub 1. So 5 times 5 is equal to, I don't know y, but I'll use the y sub 2 here and x sub 2, so y times 45. I'm going to solve this equation, so I have 25 equals 45y. Divide by 45 to figure out what y is. 25 over 45, they're both divisible by 5, so I get 5/9. Number 20. Y sub 1 varies jointly as, so I'm going to go to the denominator with x sub 1 and z sub 1. And that then equals y sub 2 over x sub 2, z sub 2. Plug in your first set of data, we'll call those the sub 1s. So 6 over 4 times 12. That's, of course, going to be 24. I can simplify the whole fraction to 1/4. But let's continue the other side. We don't know why. The x was 24, while the z was 5. So 6 over 24, simplify to 1/4. Oh, sorry, I don't know why I said 24. I keep saying 24. That's a 48. 6 over 48 won't simplify to 1/4. It'll be 1/8. 1/8, okay. Over, or equals y over, that would be 120. So cross multiply, 8y equals 120. Solve, divide by y, so we get 15. Number 21. Let's see, okay, sales, I'm going to call that S, varies directly with the amount of money spent. I'll just say M for money. So it's a direct variation, sales to money spent. So S sub 1 over M sub 1, S sub 2 over M sub 2, because it was a direct variation. So we had an S sub 1, M sub 1 value. 10,000 were the sales, 2,000 was the money spent. We'll simplify that. Here we're spending $1,200. We're trying to figure out what the sales will be. So 10,000 over 2,000, that's really 5 to 1. Cross multiply. S is going to, so 1,200 times 5, that's going to be $6,000 in sales is what they can expect. And number 22, distance, we'll call that D. A car can travel on a certain amount of fuel. So they're kind of, this piece right here could get confusing. The amount of fuel should stay constant. Notice down here, 10 gallons of fuel, 10 gallons of fuel. So it is constant. We're not really worried about that part of it. That's not really an important part of the question. If they were different, that becomes an issue. So the distance they can travel varies inversely with its speed. We'll call speed S. So distance varies inversely with speed, so d1 s1 equals d2 s2. So 50 miles per hour, that's your speed. Your distance is 336. So 336 times 50. We're trying to figure out the distance when the speed is 60 miles an hour. So 336 times 50, that's going to be 16,800. is equal to 60d. Divide by 60, we see the distance would be 280 miles is how far he would go if he's driving 60 on 10 gallons of fuel. Thanks for watching.